Yeah. And right, we'll make a start. So, hi everyone who's joined so far. Welcome to another session of our BI and data webinars, brought to you by Robert Walters. Today, we're joined by Matt Tubb, Senior Solutions Architect over at Capgemini, and he'll be providing an overview of the data mesh and its use within analytics environments. Now, as always, before I pass you over to Matt, just a bit about myself. Just have the next slide, please, Matt. So for those of you who don't know me already, my name's Chris Ingman, Senior Recruitment Consultant over at Robert Walters, specialised within business intelligence, data, analytics. I'm also the founder of the Leeds Power BI User Group. I co-organised the Manchester Power BI User Group as well. And like I was saying to Matt earlier, as the years wind down a little bit, but in January, I'm expecting a real influx of roles. A lot of clients we're working with are kind of saying, look, let's write off 2020 and start again in 2021 fresh. So I'm expecting, a lot of new positions to come up. So if you're in a position where you're looking for something new or know anyone who is, feel free to get in touch. More than happy to help. Just have the next slide, Matt. It just gives an overview of the typical roles we tend to work, because a brief overview, but not limited to. On the flip side as well, if you are looking to build your team out further, if you are looking to hire in the new year, again, feel free to get in touch. We can provide information regarding the current market, trends, average salaries, so on and so forth. And like I say, we're more than happy to help. So my detail at the bottom of this slide, feel free to reach out. And just next slide, Matt. So also, just in case some of you weren't aware already, we did complete a pre-recorded webinar series entitled How to Implement BI into Your Business. This is still very much live, open for anyone to join. Basically, it's just various different areas in which people need to take into account when implementing BI into a business. So whether it be laying the foundations, data warehouse architecture in Azure, architecture in AWS, and how to implement and roll out Power BI. So all with different speakers, obviously specialised in their specific subjects. And again, I'll post a link in the meetup page. So if anyone's interested in joining, feel free. And next slide, Matt. But that's all from me, really. So I'll hand you over to Matt. So throughout the session, I will be manning the chat box. So any question you might have, feel free to put it in there. I'll give it to Matt at the end. So we'll just do a 10-15 minute Q&A at the end of the session. What I'd ask is for everyone to turn the mics off and the video, just to make things run a bit smoother. And that's all from me. So Matt, over to you.
Thanks, Chris. Hello, everybody. So I'm going to talk you through an overview of the data mesh, which is quite a hot topic. Just a little bit of context setting. We all know data is really pervasive. It's absolutely everywhere. Some people say it's the new oil. It helps decision making. Insight-driven activities really help businesses in general. Digital transformation and modernization and enable a data-driven enterprise. A couple of facts about data in 2020. Well, quite a few facts actually. 90% of the data that we have in the world was created in the last 2 years. It's about 40 trillion gigabytes, although that's open to interpretation. I've seen 59, which it's 40 zettabytes, sometimes referred to. Every person at the moment generates 1.7 megabytes of data in a second. 97% of organizations are investing in big data and AI technologies. And 93% of enterprises have a multi-cloud strategy. So that's where you use one or more cloud vendors' technologies and cherry pick perhaps the components with which you use. 95% of businesses say that they're having troubles with unstructured data, and in the US, poor data quality costs the economy there 3.1 trillion, or costs 3.1 trillion yearly, which is a horrendously large amount. So I'm Matt Tubb. I work at Capgemini, as Chris said. I'm a senior solutions architect, and I work at the intersection of data engineering, data science and machine learning, and solutions architecture. I have done for quite a few years. What we're going to cover, obviously an overview of the data mesh. We're going to go into how we got to being here, how we got to a data mesh. What is it? What is it used for? And the benefits and challenges of using a data mesh. And then, as Chris said, Q&A afterwards. So what is a data-powered enterprise? I've cited this from a Capgemini report, a recent Capgemini report from Capgemini's research team. which is all about the data-powered enterprise. So in order to be deemed as a data-powered enterprise, you have a number of things that you would generally do. Identifying data sets, collecting lots of data, designing it, scaling infrastructure and tools, processing data, activating it. There's a whole piece around nurturing skills and cultures, unlocking value from data. These are all things that I shouldn't come as a surprise, really. So on to a little bit about how we got here. So we started off with relational database management systems, lots of structured data, lots of transactional data going into a repository, and it might be analysed, it might be used for something, it might be part of another system, a bigger system. Then we migrated to, or a lot of people migrated to a data warehouse approach. So that's where, for those of you who don't know, it's where you have a large centralised system which takes lots of data from other systems or externally or APIs, or the internet, wherever it may come from. You end up pushing it into your central data warehouse. It's normally structured data, and you can create subsets of that. You can see DM1, DM2, and DM3 there. EDW, by the way, is Enterprise Data Warehouse. So the DM pieces are called data marts, and that might be a customer data mart there where you specifically only want to access data about your customers or billing or whatever it may be. Now we pull data in there, we push it out to analytics, to operations, to other systems. Sometimes you might have more than one data warehouse in an environment as well. And the evolution of that was the data lake, or Hadoop as it originated as. Now, a data lake is set up originally to deal with unstructured data and semi-structured data, so pictures, audio, machine, long strings of text that a machine generates or numbers that a machine generates. And the difference here is it deals with that type of data, but it's also cheap, cheaper generally, and it scales really well. So same principle, you pull in your data from wherever it comes from, you load it into your data lake. The difference being here that you transform it when you pull it out most of the time. You can transform it and push it back into it, but most people will transform it and take it somewhere else. So that could be for analytics again, for operations, for other systems. And you may again have one or more data lakes in your environment. Both of these approaches to data are generally around creating it to start with, and that's around the business domain. And this could be, your external stuff as well. But if it's created within your business, it's generally a business domain creating it. And then various parts of an organization will ingest that data, they'll store it, they'll use it. So it'll flow into a system somewhere, and then it might flow into another system and be used. You might have duplication of that data. You may have you may need it to be served for consumption for analytical purposes, or for auditing, or for pushing into another system. And then the challenge here is that it works quite well, but it doesn't scale particularly well, and you end up with a lot of duplicate data, or data that's sitting there that you don't necessarily know is there or isn't generating value, and sometimes it's inefficient and it can be costly. That brings us on to a data mesh. So the data mesh, in essence, is a layer or a tool set, an environment that you connect to your data sources, and these data sources are your the systems that your domains will use. And then on the other end, you connect it to your analytics tools. You give people access to it, and that might be as if it's like a marketplace. So I'll go into it in a bit more detail in a second, because I realise that's quite a vague description of what it is. If you imagine this layer here in the middle, the data mesh, there's some key things that define it. So firstly, the data comes from the business domain. So it's from those systems. It might be a product system or a billing system, or it might be your social media data. Now it's in that domain, and a domain can be a system, it can be a department, it could be an algorithm. It depends how you want to classify it, really. Then you've got domain-driven interconnectivity. So that's where each domain is connected in some way or other, and I'll get onto that in a second. And then we have infrastructure as a platform, which is, a shared platform essentially. So moving to this approach, you remember the last one where we say we create data, it's ingested and stored and transformed, and then it's served to the business. What we have here is a slightly different approach where we create it and we store it, but that's in the business domain. So again, think of a product system or a billing system or something like that, where it's held. Now the difference here is that system becomes the owner of its data, and it's not held elsewhere generally. So the business domain becomes the steward. The business domain is responsible for the accuracy of it and the ownership of that data and how it is used out in the business. So the enterprise, or the rest of the business, pulls data from those repositories using the data mesh. Now the reason that's different is because the previous technologies, you would normally push the data into a repository, or you would push it to someone to use, or you would query it with SQL, or query it in a way that you're accessing one of the centralized marts, one of the centralized systems. Now this, you're not writing any code. You're going to an environment, which again, it's easy to visualize it if it's a marketplace. So going to a marketplace, you're seeing a catalog of data or a catalog of domains. You say, right, I want to go into my product domain. So then you go into there, you'll see all of the data that's available to you, but it will be named in it wouldn't have an ambiguous name, basically. So you wouldn't see field 673A. You'd see something that makes sense for the organization. And when you want to access it, you click it, and then you go into it, and you're pulling it out, basically. So the change here is data becomes a product, a business product. So in the tech stack, bear in mind we're talking about data as being a product here. So within that, this is the mesh enlarged, basically. So we've got all the data sources down the bottom, and those are the domain data sources, so the product itself. And then at the top, we've got the consumption layer, so that's the consumers of that data. So that might be the business applications, the analytics teams, devices. It really can be anything. In the middle, we've got a data integration layer, and that is, I've called it a data integration layer. Sometimes you might see it called as a data visualization layer, or a data virtualization layer, sorry. But there's a number of different technologies that could be. It could be a graph environment. It could be a data virtualization environment. Now, the consumption tier at the top, they don't need to know any of the complexity that happens within that layer, within that data integration. They don't need to know They don't need to know how it was transformed, although they can find that out. They don't need to know what happened to the data. They don't need to run any complex queries. They just grab that data that they want and off they go. It's secure. So one of the key tenets is you can govern who has access to individual data items. So if you have a medical system, you wouldn't necessarily want everyone looking at personal symptom or drug results or something like that. But you might want people seeing something around the name and address, something like that, if you need to send medicine out. So it's real time. And if I use the example of a data virtualization tool, so you could have one or many of those sat within your integration layer. And what a data virtualization tool does is it's just sitting in this layer, and it facilitates this shopping mart for data. When you want to pick up your address field, let's say, all it's going to do is it's going to it'll connect to the original repository that comes from, or multiple repositories, and those will be in the domains that you're looking into, and it will run some code. It will push that code down into the source system. So if it's the data warehouse that I left there, it's going to potentially use SQL. It will run some SQL. It will push it down into the warehouse. That SQL will run. It will pull the data out into the virtualization tool that sits within this integration layer, and it will cache it into memory so that it's available for a period of time that anyone can access. And that gives it a real-time sort of on-the-fly ability to hit that data. And if something changes in the source system, your data integration layer is constantly checking to see whether that has happened within the confines of that data item within that domain. So it's constantly checking. If something changes, it will either wait for someone to request it and then rebuild the data and push it into memory, or it will push it in there immediately. It depends how you set it up. So transformation logic still has to happen, the data engineering element of this, and that sits within the data integration layer. So what you're doing is you're effectively moving your data engineering function out of a big system, and you're putting it into a number of domains which have their own systems, and you're putting a small bit of it into, or a proportion of it into, this data integration layer. So in terms of teams and the domains that I mentioned, so let's focus on those. In terms of the people that you need in one of these teams, what I'm saying is we're moving from a team which potentially used to get data, put it in a system, and then there's a script that pushes it into a warehouse or into a data lake. And what we're saying now is that it's going into the system that holds it, captures it originally, but we're not pushing it into a new system now. So you need a team that has data engineers, potentially infrastructure engineers, and they would make sure that that data is of the best quality that it can be, and the best in the best form and as accurate as it can be. Then sometimes you see a data product owner within that team as well. A data product owner is essentially the business domain expert who's tasked with understanding that data from the domain perspective. cross-functional skills are really important in this. So this domain would be the product system domain, for instance. You would have all of these people sitting in this team, and they would be able to cross-fertilize ideas. What you find is your data engineers and your infrastructure engineers become more skilled in the domain itself. And you find that the more business-focused person becomes more data literate. So it's a catalyst for growing a data enabled business, or a data-driven business. And because you have multiple domains, you end up having multiples of these teams. You still have a data engineering element within the mesh itself. So if you remember that data virtualization example I gave, your technology is there to facilitate data from source system to consumer. Now, somewhere along the line, you have to do some transformation between source system and consumer, and most of the time it's done in that mesh. So you have a core data engineering team that sit within that mesh, work with that mesh, and their job is to write the logic, write any additional logic to transform data between domains. So sometimes you might have, let's say you've got a billing domain and a customer domain, and they both have customer addresses. One may be formatted differently to the other one. I don't know, postcode's always a challenge, or phone number. So phone number, let's take that. Phone numbers can be formatted all manner of different ways. But you know that you want to put, your consumer likes to view it in +44, whatever, with the rest of you. So your logic in the data mesh is going to dedupe it against domain versus domain. Remember that you would never allow your data mesh to take data from a domain that is not seen as being very accurate or as good a quality, as best quality as it can be. So you're only ever going to push in or make available the best quality data you can do. So we would dedupe the phone number, we would assess the formats of it, we would combine, aggregate, whatever we need to do is done in that mesh, and then it's served to the consumer. And again, it's real time. So in terms of the mesh itself, and what are the benefits of it? There's a number of benefits. Firstly, it provides a unified data governance and data management capability. So it's that marketplace where only good quality, accurate, well-managed data goes, and then anyone in the business can get access to it. It's traceable in the same way that you might use a lineage tool to see where did the linear regression model take its data from and what transformations did it make right back from the linear regression model to the raw data itself. And you can track that. The difference to a cataloging tool or a cataloging application is that you can access the data as well, rather than viewing it and seeing what was done to it and then going out to access it within a different system. One of the big strengths is it's an abstraction tool. So you abstract the logic, so you're taking away a lot of the transformational activities that you would have to do to push data into a data lake or into a data warehouse, and you're writing it within one place, within this mesh. Because it's in a mesh, you shouldn't need to keep doing data wrangling. So you shouldn't need to keep changing data and keep adapting it, aggregating it, changing it. There'll be times when you will, but if you do, you can always push that logic back into the mesh, and the mesh will take over for you, and there it's available immediately. You can decouple or it decouples the infrastructure from the end user, from the consumer. So you could, let's say you're using on-premise technology at the moment, so an on-premise data warehouse, and you want to migrate to the cloud, whichever vendor it might be, and store your data in there as an enterprise, as a strategic decision. The decoupling nature of this means that the end user will never know that you've made that change. They'll still see the same data. They'll still see that same marketplace. They'll still hit I want to see the KPI figures, or I want to see the name and address details, or the transaction information, or whatever it may be. But it won't change from their viewpoint. It's just the logic which sits within the mesh that's changed, and the connectivity, obviously, to the system of record, or to the domain itself and that data product. It works really well with Agile. So if you have if you ever work with an Agile environment, it really does scale well, and it really does enable you to onboard new data sets, new domains, new data products really quickly and really easily. And from a hypothesis-driven analytical perspective, if you need to start looking at a new piece of open data that's just become available, you can pull that into your data mesh really quickly, and then it's available for everybody. It's consistent. It gives you a coherent and consistent access to data across the whole organization, or whoever you want to give it access to. Like I said, there's a security element here, so you don't want everybody seeing everything, but you can, as with any system, you can shut down or expose whatever you need to. So that's so on the challenges side, everything has challenges and trade-offs, as a mesh does too. So it can be costly sometimes. Generally, the higher the complexity, and the higher the need for transformation, then the more costly it will be. There can be some times where latency is a factor. So if you operate a multi-cloud, so if you have more than one cloud, if you use more than one cloud vendor, and let's say you use Azure and you have an Azure data lake that's in Germany, in the data center there, and your data is residing there, and you use AWS and you have an S3 bucket sat in America, then you've obviously got a latency challenge between those two repositories anyway. But adding a data mesh, it can deal with that, but it's additional latency. So it would have to reach out to Germany to pull the data. It would also have to reach out to America to pull the data. It will have to wait until whatever it's getting is cached in its own memory. Then it will do its transformational logic, and then it will be available to serve it or for consumption, which can be a challenge. But with good design, it doesn't necessarily mean that it is a challenge. One of the organizational challenges is culture and commitment to use it. So obviously you need stakeholder buy-in, you need consumers buy-in, so the consumer of this data, and they need to understand that it's a trustworthy data source. It's more trustworthy than using unknown data sets or logic or a repository that's built off of 3 others that you don't necessarily know the transformational logic, or where that data originated. The culture change comes from the building of the teams within the domains, the shift of the focus from pushing data into a repository and then serving it out to you're migrating your viewpoint to the domain model, so the data product model, so the domain owner product, and they then serve it to the business whenever the business needs it via the pull mechanism that the data mesh provides. There's always, I mean, a lot of people see a data mesh as a golden panacea to all of their data problems. And if you put one in, it will allow you to combine everything. Everything will become in a great format, and it's really usable and easy to access and to find. That can be true, but at the same time, it's the age-old adage of if you have rubbish data and you put it in something, and you still have rubbish data at the raw level. So your mesh may take away some of the challenges about that data being difficult to use. And there's a trade-off between, is it cheaper to fix your underlying problems in your data or some of the big challenges that exist? So formatting between two massive systems, between two data lakes, for instance, that hold petabytes of data, it might be better to do that change within those rather than have the mesh do it, because it would be doing that change on the fly every time it runs, basically. Sometimes there's a view that a data mesh can be that centralized system that stores all the data, which if you're not careful, which can end up meaning that the system becomes like an old data lake or like a warehouse, and it can become monolithic, and you're essentially removing the reason why you put it in there in the first place. And then it's also an evolving area. Evolving area, which is changing and growing weekly or regularly. So there's new tech, there's new ways of doing things. There's rumours that Microsoft might be looking at data meshes. I wouldn't be surprised if some cloud vendors are. But it's open for a lot of change. So just to summarise, data mesh is a really strong, powerful tool. It is very, very good if you have lots of different sources and you want to onboard them over time into your mesh, but you don't want access to them all immediately. Now, it gives the consumer of data, so the analysts, your data scientists, anyone who needs to access data, a system that needs to access data within your environment, gives them domain-based access really quickly to a large catalogue of data that's standardized across your entire organization. It's governed, it's managed, it's a single source of truth. But it does come with some challenges, as I've said. So that was a whistle-stop tour of a data mesh. Thanks for listening. Over to Chris for questions.
Yeah, thanks, Matt. That's really interesting, actually, and we've had quite a few questions, to be fair. Okay. So we'll get straight into them. Apologies if my inflection's a bit wrong when I'm fashioning these. It's quite difficult sometimes, but I'll do my best.
Okay, sure.
So the first was from Dave Paul. This is going back to relatively early in the presentation. I think he just wants a bit of clarity. So he said, so the business domain is in charge of security, governance, quality, and a whole host of functional and non-functional requirements.
Is the business domain?
Yeah, it is. Yeah, basically.
Yes, it is. Not necessarily the security, because that's dealt with by the mesh itself. They would need to make sure that their source systems are secure anyway, but that should be there and in place already. The main point is that the domain is, well, the data product that sits within the domain. It's about ensuring that the data is available and is accurate, and that the business domain owns it and becomes the steward in more of a data governance and data management perspective. They take ownership of it. All the normal security layers would sit around that system, as it would do around the mesh itself. The mesh is just going to connect up to, it's going to interface into this system, and then when someone needs it, they'll pull the data, and it will essentially extrapolate through from the source system into the mesh to the consumer. Hopefully that answered the question.
Great, thanks. Next, we've got Howard Wild. He asks, how do you handle performance on the domain systems when the mesh is extracting data?
How do you handle what, sorry?
Performance on the domain systems when the mesh is extracting data.
That's a good question, actually. So you may need to look at the performance of the source system itself. You may need to tweak that. So it may need additional cores, it may need additional processing power or space. But in general, your mesh should, it's a bit of an open-ended question, really, that one. So it depends on what you want to do with your mesh, whether or not you need access to the source system data constantly, which would mean that you're going to hit your source system when there's peaks. You could say to the mesh, only hit it when it's a trough, when you're not actually getting, when you're not actually using it. But that would mean that your mesh is storing data longer than you would necessarily want it to, caching data, that is. And the mesh itself has a component which you need to look at for performance, and a component that you need to look at for in-memory storage. So you need to design it correctly, is where I'm going. You need to ensure that the source system can handle the perceived queries that your mesh is going to be making to it.
Cheers. Next, another question from Dave Paul. Again, I'm just going to have a bit more of a clarity, but he says, would it be fair to say that the business domain has its own nearline data warehouse?
The business domain, kind of. So I wouldn't say, yeah, sort of. So because your mesh is as near time as it gets, your business domain can always access the mesh. Therefore, it becomes its own environment. But if your business domain is allowing all of its data to go into the mesh, then you're just seeing the same thing, right? Your business domain team may still need to use your source system in the same ways that it's already being used. You don't always have to stop that. You could change some of the pipelines and some of the processes to hit the mesh itself. The real value here is where business domain A and business domain B connect their data together, if it can be, in the mesh, so that business domain A can get the value out of business domain B's data as well, or anyone else for that matter in the organisation when they're hitting the mesh.
Great, thanks. Now next we've got quite a few questions from Bilash Dash. So yeah, I'll just ask them all. I'll do one at a time. So first one, what sorts of different workloads can the data mesh support, and would that meet the enterprise information needs, or would it be limited to a set of capabilities?
Again, it's a depends answer, that one. It depends what your use case is, and it depends how you need to use it. So there's a lot of meshes are used. Some meshes are used to fulfill a combination of domains needs. So you're combining, let's say, 3 or 4 or 5 domains data together, but there'll still be other systems around. Sometimes you'll see people trying to put a mesh across the entire organization, for which is what it's designed, originally designed for, but it doesn't always work. It's a very design intensive activity. You need to onboard, as I said before, you need to onboard everything, the domains separately, or it works better when you do that. But it depends on the use case, really. That's a bit of a vague answer. It depends on the use case. It can facilitate most of the analytical use cases that you would need. So you can connect up Power BI, you could connect up Tableau and interface directly through an API to your mesh. You could, you hit those data points in a batch kind of way, or even bespoke, just wherever you need to hit those to run those reports. You could do Python-based machine learning if you needed to. Obviously, your Python scripts and your machine learning would run in your Python environment separately to your mesh, but you're still hitting the mesh for the data that you need. Similarly, if you're just looking to get a tabular output for something, then you can do the same thing. You could connect other processing systems to your mesh, but then it becomes more like a monolithic data store, or a centralized warehouse. And that's the thing that you don't really want to do. It defeats the point of having a mesh in its own right. Hope that answers your question.
Cheers. Like I say, we've got a few from Bill Ash. The next one, and apologies if I'm saying this wrong. So what are the various access mechanisms to consume the mesh data?
Again, it depends what you want to use, which technology you use. So there's loads of different vendors out there. Most of them will offer API. Most of them will offer CLI. Some of them will give you GUIs. Sometimes, as I said just then, you can connect up your existing applications to them. It just depends which tool sets you end up putting into your integration layer.
Cheers. And next from Bill Ash is, where and how do you manage the metadata of the mesh? Then he goes on to say, would it provide the provenance of the data being an aggregator, and how that can be assessed by the consumers?
Sure. So it can store the metadata in itself. That is part of the point of it. So you've got the aggregation of data side and serving that out, but you've also got the data governance and data management side of it. So it keeps you can store any metadata you need to within it. you can push out to other repositories. So if you needed to constantly store metadata about lineage or access or whatever it may be, then you can export data into a persistent store that you can then use as a node within your mesh. So every domain and every system that you connect to a mesh is called a node. So that attached storage that you connect to your mesh becomes a node, and it just becomes part of your mesh, and you can write to it as you wish, or you can process it as you wish. And it allows for you to do things like assess lineage and have a catalog, and it's part and parcel of the mesh. It depends which technology you're using within it, or groups of technologies, but absolutely it does that. In terms of provenance and assessment, it depends which tech stacks you start looking at. So you could attach a Calibra if you wanted to into your build or into your architecture, which obviously allows you to look back through your data. You could use some of the functionality that sits within a Denodo, for instance, and that would allow you to do a similar thing. It depends on the tech stack you decide to use and the architecture that you design within that layer, that integration layer.
Perfect. And Balash just asked as well, what are the different products in the market to support data mesh? Sure. That you know of?
I know. Well, there's loads. Some are a mesh. Some are formally called a mesh. Some are not formally called a mesh. There's a really useful Forrester report that will detail lots of them for you. I think it's called the Forrester Enterprise Data Fabric Q2 2020. I think it's called. If you search for Data Fabric Forrester, you'll probably find it. And in there, they've tested out loads. So there's Denodo's really, they've gone quite hard on Denodo. They've looked at SAP, IBM. They've gone to Talend, Tibco Unify. There's a whole suite in there. I think there's 12. 3, 6. There's over. Over 12 that they've looked at, but there's loads, and I could sit here reading them off for quite a while. I can do that if you want me to, but it might be easier to look at the Forrester report and see what's out there. There's new things coming to market all the time. It might be useful for me to say which ones Forrester's report says are leaders. So they've got Talend Data Fabric. They've got Cambridge Semantics Anzo, which is their graph technology. They've got IBM Cloud Pak for Data, almost in there. Denodo, Denodo's platform is in there. They've got a suite of Oracle tech in there, including Golden Gate, Autonomous Data Platform, Cloud Infrastructure, and Analytics Cloud. And those are the ones that Forrester suggests are leaders in this field. But I suggest having a look at that report.
Great, thanks, Matt. I'm just conscious of time, so I'll give someone else an opportunity to ask a question. We've got Mateusz, sorry, I can't pronounce his surname, but he mentioned, look, this may be a long shot, but from a commercial perspective, does data virtualization solution provide return on investment?
It can do if it's done correctly, and if it's done quickly, then it can do. And if you're doing a takeout, for instance, or if you've got a number of different repositories that you can condense down because you don't need to extrapolate data and transform data between system 1, 2, and 3 to then give the output to your data science community. You could do all of that logic within your virtualization toolset. Then you're clearly going to make a saving by removing those pieces of technology, both from a license perspective and a performance and usage from a performance perspective as well. So you might get more efficiencies out of everything, and data to your end users faster in some respects. But it will really depend on how quickly you can get data into your environment, into your mesh, how you've designed it, and whether you've designed it to deal with latency, whether you've designed it for the use case that that you originally said. Is it for analytics? Is it for something else? And whether or not you're hopping between loads of different clouds, which is the latency point again. But you can make a return on the investment. Yeah, definitely.
Sorry, Matt, I cut you off there. Just finally then, last question, we have Howard Wild, and he asks, have you seen this implemented for real? What was the tipping point for the business to agree to go with the mesh?
I have seen it implemented. We're talking with a couple of clients at the moment about data meshes as well. The tipping point, so I've seen it implemented well, and I've seen it implemented not so well, or with challenges. And when it has challenges, it means that you have to spend a bit more time to fix it, obviously, which is why we would always suggest to do an agile onboarding of domains, small domains over time. But I've seen it done in the retail sector, and as to how they sold it in, so to speak, to the stakeholders, I don't know exactly what they said, but most of the time, the reason why you're putting it in there is for centralized access to the data, to enable to take out some complexity, be that systems or transformations or logic, to simplify or to create efficiencies generally. Hopefully that answers your question.
Great. I think that's it for questions. We've got someone who'll provide a bit of a further insight into some of the questions in the chat box as well, which is great. But otherwise, that's everything. So I just want to say a big thanks to you, Matt, for today's session. It's some good questions there as well, and you answered as well. So I'm really, thanks for taking time out to do this. The session is recorded, so if anyone needs to catch it again, it will be on. I'll post it on LinkedIn later today, just once it's processed. We just have the next slide, Matt, as well. So this is actually the last session before Christmas, as you can imagine. I think everyone's kind of finished with 2020 for now. So we will be continuing these webinars in the new year. I'm looking for speakers, really. I've not really thought about it much, but yeah, so speakers in the new year. So if anyone is keen or want to hear about a specific topic, just let me know. More than happy to put something together. And as always, my name's Chris Ingman, and my day job is recruitment. So if you are looking to find a new job for yourself, or someone's looking, or alternatively, if you're looking to grow your own team, feel free to get in touch here. My detail on the slides. Just have the next slides, Matt. Just want to wish everyone a happy Christmas and a new year, and thanks for your support throughout the year, and hopefully see you soon in Jan.